Hey everybody, it's Greenwood again with another tutorial video, and today's video is on special right triangles. And there are two types of special right triangles, the 45-45-90 and the 30-60-90. And so these names refer to the angle measures within the triangle. And so the 45-45-90, as you can see I'm drawing on here, is an isosceles right triangle because two sides are the same length. That are across from the 45. So one big understanding is to know that whatever the side is across from an angle, the bigger the angle, the longer the side. So for example, if I'm looking at my triangle here, this is a 90-degree angle, and the side across from 90 is called the hypotenuse. So I'm just going to label that with an H. And that's always the longest side in a right triangle. The other two sides are across from 45-degree angles. So since 45 is less than 90, this side labeled n has to be shorter than this side labeled n square root of 2. And since these are both across from 45s, they both have to be the same size. So I'm going to call those both L for leg. So the non-hypotenuse sides in a right triangle are called legs. And these two are the same. So that's kind of our first two steps. Step one is to recognize a special triangle, and we can recognize it by its angle measures. Here's one type, here's another type. In this video, we'll be talking about just 45, 45, 90-degree angle triangles, and all those that are similar, having the same shape but different size. If you can imagine on your phone or your tablet, if you pinch, make things smaller or stretch them, it changes the size of the figure. Like if I have a picture of my dog, for example, it doesn't change the shape of my dog or what my dog looks like. It just makes my dog bigger or smaller. And that's what similarity really is. And so all 45, 45, 90 triangles, it's like my dog. If I stretch them and make them bigger, or pinch them and make them smaller, they're still similar and have the same ratio and proportion. So with that definition, part two is to identify the parts. That's the hypotenuse and the leg, which we've labeled H and L. Step three is determine which part that you know about the triangle, which this is my shortcut, so we'll talk about how to use that here in a minute. And then step four is to apply the pattern. And then step five is to simplify. Step five we'll call an extension step, which I won't discuss in this video. All right, so step four, applying the pattern. So you can use a squared plus b squared equals c squared or the Pythagorean theorem to determine a couple of things. So there's one pattern that happens with the this special triangle. So with the 45, 45, 90, these two legs are always the same. So if this side's 8, this leg is also 8. This leg is 4, this leg is 4, and literally doesn't matter. This leg is chicken, this leg is chicken. Okay. The pattern that happens is going from the leg to the hypotenuse. Now, this square root of 2, I want to be very careful and caution you that 2 does not equal the square root of 2. The square root of 2 means what number times itself gives me 2. And if you use a calculator on that, it's 1.4, I think. So let me pull up a quick calculator here. We'll clear our work. All right, so the square root of 2, yeah, it's like 1.414. So that's what the value of that side is, or about 1.5, okay? Whereas 2, we know, is just 2. All right, so that with that, if you use Pythagorean theorem, you'll find the pattern that to get from the leg to the hypotenuse, so if you know the leg, you multiply by the square root of 2 to find the hypotenuse, and you divide by the square root of 2 if you know the hypotenuse and want to find the leg. Okay, so with that knowledge, that's the pattern. That's what happens. So let's look at a few problems and see how you might implement this. Okay, so I'm going to identify, yes, it's a 45, 45, 90. This is my hypotenuse. That makes this a leg and this a leg. And so since I know this leg is 3, the other leg has to be exactly the same. That is also 3. Since I know the leg to find the hypotenuse, I multiply by square root of 2. That x is a times, not an x variable. So this I would just write as 3 square root of 2, or 3 times square root of 2. In your calculator, you can get a decimal value, but we really are concerned about having the exact value. And now if you do this in Mathia, it will calculate the value for you when appropriate. So if it asks for a story problem, wants a decimal, it'll calculate the decimal for you, okay? With this one, again, same idea. I know leg is 8, That's a leg. This is the hypotenuse. The hypotenuse is always across from the 90-degree angle. So I always like to find that right angle. Since this leg is 8, this leg is also 8. And the hypotenuse would be 8 times the square root of 2. All right, here's a couple more examples. Find your hypotenuse, always across from the 90. I'll do it for both of these real fast. There's my right angle. I can't stress how important labeling is for these types of problems, so you can see what the parts are. And if you know what the parts are, you just have to be able to apply the pattern. No big deal. Okay, so I know this is my hypotenuse. It's across from the 90. These two are my legs. Same story over here. You should see some patterns and some similarities because they are all the same triangle. They're just different sizes, bigger or smaller. Okay, so this leg is 3 square root of 2. So this leg has to be exactly the same, 3 times square root of 2. Now, if I flip back to my calculator, 3 times square root of 2. So that's about 4.24, all right? And so that's what that length is, 4.24. This one's also 4.24. Now, to get to the hypotenuse, we're going to multiply this leg by square root of 2, just like we did before. The only thing is my number looks a little different here. So we have 3 square root of 2 times square root of 2. You can simplify and leave it as that. You can type in your calculator. If you get a whole number, great. But Matthew will simplify that for you. So 3 square root of 2 times square root of 2. So we take 3 square root of 2. Make sure you arrow out from underneath your radical times square root of 2. And we get 6. So that means that this simplifies to 6. And you'll see the same thing happen here. Okay? In the next video, I'll talk about how to go the other way when you know the hypotenuse. And I hope this one helped you. We'll see you in the next one. Bye.